All right, this is 5 real zeros of polynomial. We skipped 5 4 because that was inequalities, and that was a disaster last time we did inequalities, and I just didn't want to go down that road again with y'all. So we're doing 5 real zeros of polynomial. They've got a theorem here. It's written in math speak, which is kind of weird. So I'll make up a better example and delete this little theorem. Anyways, let's say we have some polynomial f of x, and it is 4x to the second plus, I don't know why I said second, I'm going to go higher than that, to the fifth plus 3x to the third there we go, plus 2x minus, I don't know, 8. The theorem says the possible, doesn't mean they are, the possible fractional zeros for f of x, this function above, are at the factors of 8 divided by the factors of 4. If it has a fractional zero, that's where you find it. Now your book will use the letters P and Q, and that's what this book will do. That's what most books use. Yep. Does anybody actually use your book for assistance? Anybody ever look at that big blue book? No? Okay, then I'm not going to teach the little book this. Book likes to use letters P and Q. Huh? You know where it's at, or you don't know where it's at? I'm pretty sure I'll get here. Hope it shows up by graduation. Otherwise, you owe me a book. I always call the last guy C and the first guy A. That's kind of how I think we should teach algebra too. Factors of C, the constant, over the factors of A. I'm not going to actually use this one example as where we write out the list of potential zeros. I'll use the next one for that. Do you remember writing out lists of zeros? One huge skill I really pushed. I am recording. I am recording. Does anybody remember writing out lists of zeros? Making? Well, you're 2 years removed. That wouldn't surprise me. But you did this last year. I promise you did, or the year before. Every year. So if there is a zero, it's going to be in the list that we make, and we'll use the next example to make up that list. So you might need more time? All right, so list the potential rational, your book uses the word rational zeros of this guy. Well, the idea is that you find the factors of what number? Factors of 12. That's not negative, just 12. Over the factors of 3. Now, you just got to think to yourself what the factors of 12 are. It's 1 and 12, right? 2 and 6. What else? 3 and 4. And it could be a positive 1, a positive 12, or a negative 1, or a negative 12. So we use a plus or minus. We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. It always confuses the chunk of juniors when you write it out like that. You guys understand what it means. The outside makes 12, right? Move in one level, makes 12. Move in another level, makes 12. Over the factors of 3, and over the factors of 3. Plus or minus 1 and plus or minus 3. That's your list. You just reduce it down. You have the potential zeros. So you go through and you divide everything by 1. And after you divide everything by 1, what do you divide everything by? 3. All right, so our list is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That's the division of 1. And start dividing by 3, and you'll see some new ones show up. Like you'll see plus or minus a third and 2/3. They'll be new, won't they? Then you do 3 over 3. Is that already in your list? You don't write it twice. Don't repeat. There's no point in repeating. 4/3 is new. 6 over 3 is 2. Now I write it, 2 over 3 is 4. That's the full list. If there is a 0 in that function, a fractional 0 or a rational 0, it's in that list. Now, I'll show you it's in that list. Look at the graph real quick. Because this is probably what you remember doing in Algebra 2. I always told you, write out the list, but use your calculator for the assistance. We got 8 minutes left. 10. Oops. There's a 0 at what? -3? Wasn't that in your list? There's a 0 at -1. That was in your list, right? And I think there's another one over here. I'm not sure if it's at 1 or 4/3, but there's another one there. That one might be 4/3. Those are all on the list, weren't they? Yeah. Hey, this goes back, it predates technology. I've got a little question up here. It's actually got a typo on it. It's supposed to ask you, what is f of -1? How would you find f of -1? What would you do with that -1? You'd make all the x's -1, right? We're just going to do that kind of quickly here. What's a -1 cubed? Times a 3 is a -3, right? What's a -1 squared? Times the 8 is plus a negative. -1 times -7? Plus 7. And then minus 12. What is f of -1? Zero. What on earth does that mean? Well, that says x equals -1, right? It says x equals -1 is a 0. It is an x-intercept. It is a root. Now, if x equals -1 is a 0, what factor created it?
X plus 1.
There you go. Created by the factor x plus 1. All right. So anybody got any issues with that? Probably only going to do one example because you did so much of this stuff in Algebra 2 that you shouldn't need a whole lot of it. What's the objective here? Find the real zeros of the polynomial function f of x equals, oh, it's the same thing, isn't it? 3x cubed plus 8x squared minus 7x minus 12. And write it out in factored form. Now, I don't remember everything I saw on that graph, but I do know that -1 was a 0. What was another one? Maybe -3? What we're going to do is we're going to use synthetic division. We know from the graph that x equals -1 and x equals -3 are zeros. We're going to synthetically divide them out. I guess you could just kind of cheat and use everything from your graph. But not everything that you look at your homework actually has 3 real zeros. And the truth is, we're only going to divide one of them. Let me write that down in your notes. This is kind of a general idea. We're going to pull enough x's to reduce to a quadratic. That's an x cubed. How many x's do I need to pull out of it to reduce it to a quadratic? Just one. Do you guys want to synthetically divide out the -3 or the -1? It's fine with me. Okay. I'm mentioning synthetic division. Do you remember doing synthetic division? It's not hard. You should have done a crap load of it. Synthetic division, the divisor symbol is upside down. What's the top loaded with?
Your
Coefficients, right? 3, 8, -7, -12. Kelly wanted to divide out the x equals -3. I had a little acronym for this. It's always spelled not the way I wanted it. You have a drop multiply. You drop first coefficient 3. And then you multiply. It's -3 times 3. After you multiply, you add this subtraction, this addition. You get -1. And after you add, you multiply. You guys did synthetic division on Excel, didn't you? And then you add. And then you multiply. And there you are. Now that 0 represents the remainder. Just think back to algebra 2. What precedes the remainder? Constant. What precedes the constant? What precedes an x. So this is the polynomial 3x squared minus x minus 4. And we're just going to factor it. Or maybe the quadratic formula. One of the two. Whichever one works. And this one does happen to be factored. What's it take to create your 3x squared? It's a 3x and x. The factors of 4 are probably 1 and 4. Maybe. I think we need a 1 there and a 4 there. Minus plus. That was simple enough. Now, the instructions did say write this thing in factored form. What factor created that 0x equals -3? There we go. That was created by x plus 3. There, right there. Right there. And that is all the instruction I'm going to give you on this section. Because that is honestly got all the instruction you need. Remember. I reckon when I see you Monday, we'll go over your homework. For those of you at home, I will try to record us going over that homework. We'll see if I remember.